In this example, we're going to actually practice graphing a hyperbola. So here we're given the equation of a hyperbola, and we're just simply trying to graph it based off of the information that we can see here in the equation. So a couple things I see right off the bat is one thing is the center. If this is x minus h and this is y minus k, the h is 0 and the k is negative 2. And so I can see automatically that my center would be at 0 comma negative 2. All right. Next thing I need to determine is does this hyperbola open to the left and right or up and down around the point 0 comma negative 2, which is right about here. Okay. I talked about this logic in an earlier video, but basically if you let the x coordinate be at a center value of 0 and you're trying to see if there are any points on the hyperbola that correspond to an x coordinate of 0, because notice the center is not on the hyperbola, the center is just in the middle of the hyperbola. If x was 0, there's no y coordinate such that this quantity would be positive 1. It would be a negative value, not a positive value. And what that tells me is that this hyperbola is going to open left and right as opposed to up or down, since there's no y values here to correspond with the next coordinate of 0. So being that we know that it opens left or right, then let's look at the a value. If a squared equals 9, then the a is equal to 3. So I'm going to go 1, 2, 3 units to the left and 1, 2, 3 units to the right. And these are going to be my vertices. So what points are those? This would be negative 3, negative 2, and positive 3, negative 2. Those would be the vertices. Negative 3, negative 2, and positive 3, negative 2. All right, we'll find the foci here in just a minute. Next, let's actually find the asymptotes that are going to help us graph this hyperbola here. The a is 3, and let's see what the b is. If 4 equals b squared, then b would equal 2. And what we're going to do is we're going to make a very natural box that's 2a units wide, this a, and 2b units tall. So you'll go right 3 units, left 3 units, up 2 units, and down 2 units. And you see we can very, very naturally make a rectangle out of that shape. And then we're going to connect the boxes, connect the corners of this box. The opposite corners, that is. So we'll have one asymptote going through those 2 corners, then we'll have another asymptote going through the other 2 corners, and notice both of these should go through the center at the middle of the box. Right? Now, what do those asymptotes do? Well, they help guide you to see how wide to draw your hyperbola. So the hyperbola is definitely going to go through these vertices, and as you leave the vertices, then you'll go up like this and down like this and approach the asymptotes, and then do the same thing on the opposite side. So that rectangle there really helps you gauge how narrow to draw your hyperbola. So there you go. There's the graph of our hyperbola. Now it would be nice if we just finished this out and found the foci just while we're at it. The foci can be found on the inside of the hyperbola, somewhere around here and here. And they're c units away from the center, but all I see is a and b. A is 3 and b is 2. Well, hopefully you remember the formula for that relates a, b, and c together. It was that c squared equals a squared plus b squared. And so c squared equals, let's see, a squared is 9 and b squared is 4. So you have 9 plus 4 equals 13. C squared equals 13, so C equals the square root of 13. So I'm going to go to the left and the right of the center this many units. So if the center is at 0, negative 2, then I will go to, let's jot it down, we would go to negative root 13, comma negative 2, and positive root 13, comma negative 2. And graphically, this will be negative root 13, negative 2 will be here. positive root 13 comma negative 2 will be here, and that's the two foci for the hyperbola.